So this is the second video for assignment number 4. We've already looked at the unit circle and we found all of the degree measures, and now what we want to do is, and the radian measures, and now we want to find both the vertical and the horizontal components within each of these angle measures. And so let's start by, we're going to find all of these distances going around the circle. For example, we know that this is the point 1, 0. If I go directly up on a unit circle, I'm going to be at the point 0, 1. If I move directly to the left, I'm at -1, 0. And if I go directly down, then I'm at 0, -1. And so we already have those first 4 points in place. What we really need is these 3 points here, and then the 3 points that are kind of reflected around the circle. And so I'm going to focus right now first on this point right here and this triangle. We already know about vectors, and so we can consider this angle measure to be like a vector. We know that this is a 30-degree angle, or we can say it's pi/6 radians. But what I want is the x and the y components, the vertical and the horizontal components. So to figure out what x is, a couple ways I could do this. Hopefully remember the shortcut, but if we don't, let's just go through it again together. If this is x right here, and the hypotenuse we know in a unit circle is 1, that's the radius of the circle, and that's 1. And so to figure out what x is, that's the adjacent side over the hypotenuse, which is the cosine. So to figure out what x is, I'm going to put it down here, x is equal to 1 times the cosine of the angle measure, which is 30 degrees. Or if we're in radians, we can go the cosine of pi/6. Well, cosine of 30 degrees is something that we should remember from our special right triangles discussion that we had in Unit 1. If I have a 30-degree angle and a 60-degree angle in a right triangle, this is 1, the hypotenuse is 2, and the third side, the big leg, is the square root of 3. And so if I'm at a 30-degree angle, which is this angle here, and I want the cosine of that 30-degree angle, the adjacent side over the hypotenuse is the square root of 3/2. And so the x-coordinate here is radical 3, if I can put it in that small space here, radical 3/2. Let me just do this. It is the square root of 3, that's a 3/2. Okay, so that's the x-coordinate. Then I want to find the y-coordinate, which is this distance. How far up are we going? Well, this is the opposite side. I'm going to call it y, but it is the opposite side of the 30-degree angle. So the opposite side over the hypotenuse is 1. The opposite side over the hypotenuse is the sine. So that means y can be considered the sine of 30 degrees. And the sine of 30 degrees, again, if we go to this triangle over here, the sine of 30 degrees is the opposite side over the hypotenuse. Well, here's the opposite side. Here's the hypotenuse. That is 1/2. So we have radical 3/2 and 1/2. Now, I'm sure that at this point we could probably figure out what this x and y coordinate is, because it's just reflected over the x-axis. We could probably figure out what this point is, or it's reflected over the y-axis here. It's reflected over the x-axis here. And then I could probably figure out what this one is, because it's reflected over, it's 180 degrees past that, or I can reflect it here and reflect it here. It's going to be the exact same numbers, but just different signs. So instead of going over radical 3/2 and up 1/2, I'm going to go left radical 3/2 and up 1/2. So this point, let me just do this one for you, is negative radical 3/2 and then up 1/2. And I could do the same thing to find the other 2 points that we've highlighted. Let's go ahead and take a look at this one right here next. This right here is a 60-degree angle, so I'm looking at this triangle, and so the angle that I'm worried about now is 60 degrees. And so to figure out what the x value is down here, maybe I should do this in a different color. To figure out what the x value is, let me just do this color. The x value right here, again, I'm going to do the cosine. The hypotenuse is still 1. So x is going to equal the cosine of 60 degrees. Well, here's my 60-degree angle. The cosine is the adjacent over the hypotenuse, which means that is 1 over 2. And so the cosine is a half. So that means the x-coordinate is a half. Well, to figure out the y-coordinate, which is this distance right here, this is y. So if I'm looking at the 60-degree angle, it's the opposite side over the hypotenuse. Well, the opposite side over the hypotenuse is the sine. So to figure out what the y value is, I'm going to do the sine of 60 degrees. And the sine of 60 degrees is the opposite side, which is radical 3 over the hypotenuse, which is 2. So this is radical 3 over 2. So it's very similar to what we had over here. They're just switched around. I'm going over a half and then up radical 3 over 2. And now we can probably figure out what this point is, what this point down here is, and what this point is. So we have one more to do. I'm going to do this one in green. It's this one right here. If you can kind of picture this. This is a 45-degree angle here. And so the nice thing about this one is my x and my y, the x here and the y here, should be the same, because if it's a 45-degree angle, this is an isosceles triangle. And so let me look at the x first on this 45-degree angle. I know it's 45 degrees. This is the adjacent side, and the hypotenuse is 1. So I could say that the cosine is x over 1. But if I use the shortcut, we know that I can find the horizontal component by taking the cosine times the magnitude, which is 1 in this case. So x is going to equal the cosine of 45 degrees. So I'm going to put another triangle here. This is a 45-degree angle, and if we remember the special sides of a 45-degree triangle, it's 1, 1, and the square root of 2. And so the cosine of 45 degrees is going to be 1 over the hypotenuse, which is the square root of 2. So if we have 1 over the square root of 2, we can multiply the top and the bottom by the square root of 2, and that's going to be the square root of 2 over 2. And so that means this point right here is going to be over the square root of 2 over 2. And because the x and the y are the same, the y is also going to be the square root of 2 over 2. And so now I can take this point and reflect it and find this point, reflect it down here and find this point, and reflect it down here and find this point. Once we get all of those x and y values in here, here's what we also should recognize from this. That if I want to find this sine of any angle, the sine of any angle, that's always equal to the y value. So for example, the sine of 30 degrees, that's a half. The sine of 45 degrees, radical 2 over 2. The sine of 60 degrees, radical 3 over 2. The sine of 90 degrees, well, that's 1. The sine of 180 degrees is 0. Also, we can figure out the cosine of any angle. I should say any angle here. The cosine of any angle is equal to the x value. So the cosine of 30 degrees, that's radical 3 over 2. The cosine of 45 degrees is radical 2 over 2. Not only can I find the cosine of all of those special angles by looking at their degree measure, I should also be able to do something like this. If I'm asked, what's the cosine of pi over 4 radians? Well, it's really pretty easy now, because pi over 4 radians, maybe I should mix up my colors again. Pi over 4 radians is this one right here. That's pi over 4. And so the cosine of pi over 4, that's the x value, radical 2 over 2. The sine of pi over 4 is also radical 2 over 2. So not only can I give you all those values in this quadrant, I should be able to give you all the values in all 3 quadrants. Not only those 3 quadrants, but if I go beyond 360 degrees, like if I wanted to ask you the sine of, let's say I wanted to do the sine of 450 degrees. Well, that's 90 more than 360, so I'm at this line right here. The sine of 450 degrees without doing it on your calculator, that's 1. And so the unit circle is going to be very helpful for us as we finish out this unit in trig. It's also something as you move on to like a pre-calc or trig class. It's also value to have this knowledge kind of somewhere up in your brain so that you can recall it whenever you need to. I would definitely keep this paper that you have because it will be helpful not only this year but in years to come when you're taking trig. So this is the end of video 2. Hopefully you can come to class tomorrow with all of this filled out accurately, and we will see you then.